Welcome back, everyone. Today we are going to explain the physics of flight and the forces behind these physics with a little help from our trusty F-104S. But first, a little background about this aircraft. The F-104S starfighter was an Italian-produced version of the Lockheed Martin F-104 starfighter, an American-designed aircraft built as an interceptor to hunt down enemy bombers during the Cold War. The F-104S was retired from service in October 2004. Alright, now we know our plane, let's model some forces. There are four fundamental forces that govern all aspects of flight, that are thrust, lift, drag, and gravity. Let's talk about the simplest force first. Gravity acts vertically downwards towards the center of the Earth at the center of mass of the aircraft. This is equal to the weight of the aircraft and is given by W equals mg, where m is the mass of the aircraft and g is the acceleration due to gravity. Thrust is generated by the aircraft's engines and acts forward. It propels the aircraft through the air by accelerating exhaust gases backwards, and using these gases in accordance with Newton's third law of motion, where gases produce an equal and opposite force on the aircraft, pushing it in the direction of motion. Lift acts perpendicular to the oncoming flow of air and is responsible for holding the aircraft in the air. Lift acts at the center of pressure and is generally directed upwards to oppose gravity. According to Bernoulli's principle, the pressure of a fluid decreases as its velocity increases, and as the air moving over the cupped upper surface of the wing travels faster than the air moving underneath the wing, this creates lower pressure above the wing and higher pressure below it. This pressure difference pushes upwards on the wing and generates lift. Lift can also be explained using the principle of momentum conservation. As air flows over the wing, it is deflected downwards, creating downwash. The change in momentum of the airflow from horizontal to downward generates an equal and opposite upwards force, which is the lift. Drag is the resistive force that opposes the forward motion of the aircraft, acting at the center of pressure but opposite to the direction of thrust. There are several types of drag. The first type of drag is skin friction drag, that is caused by the friction between the surface of the aircraft and the air as a result of the boundary layer, the thin layer of air that sticks to the surface and slows down, creating resistance. Form drag arises from the shape of the aircraft, as objects that are less aerodynamic create more turbulent wake behind them. This wake increases resistance by increasing the amount of air that moves with the aircraft, which slows it down. Streamlined shapes, like this starfighter, reduce this form of drag. Lift-induced drag. As a byproduct of generating lift, vortices form at the wingtips, creating a rearward component to the lift force, which acts as drag. Lift-induced drag is inversely proportional to airspeed and increases at lower speeds when more lift is required. In steady, level flight, Newton's first law applies. The aircraft remains in equilibrium where the sum of all forces and torques is zero, where lift equals weight, where the lift must exactly counteract the gravitational force for the aircraft to remain level. Thrust must equal drag. Thrust must counteract drag for the aircraft to maintain a constant velocity. In a climb, the pilot increases thrust, creating an unbalanced force that accelerates the aircraft upward. Lift must still overcome weight, but the balance shifts due to the additional forward force. When descending, the pilot reduces thrust, allowing drag to overcome thrust, causing the aircraft to descend. The lift can be less than the weight during a controlled descent. During a banked turn, the pilot tilts the aircraft, redirecting some of the lift force horizontally to provide the centrifugal force needed for turning. The aircraft must also increase lift to balance the vertical component and keep the aircraft from descending. Through adjustments to these forces, torques about the aircraft's center of mass are also controlled by varying the positions of control surfaces, for example, elevators, rudders, and ailerons, ensuring stability and maneuverability. In summary, the aircraft's flight is controlled by balancing forces: thrust, drag, lift, and gravity, while adhering to Newton's laws. This is how every aircraft you've ever seen flies. Alas, the current methods of flight rely heavily on expensive, inefficient chemical-based propellants, which impact heavily upon our environment, as all gas produced by these propellants contribute to pollution and the greenhouse gas effect. However, NASA is working on an alternative that is 10 times more fuel efficient. That is, solar electric propulsion. The air or spacecraft collects energy from the sun via solar arrays to generate electricity that is used to power and ionize, or positively charge, inert gas propellants like xenon and krypton. A combination of electric and magnetic fields then accelerates the ions and pushes them out of the thruster, creating a greenish-blue plasma plume, propelling the spacecraft to tremendous speeds over time. Thank you all for watching, and see you all in the next video.